Welcome to my video on measuring and calculating the area of a parallelogram. So a parallelogram is an equilateral, meaning it's got four sides with two pairs of parallel sides. This would be like this, 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 this. And it has certain properties. Opposite sides are equal in length. So this side is equal to this side, going out to here. And this side is equal to this side. So that's what this first tells us. Opposite angles are equal. So this angle is equal to this angle. This angle is equal to that angle. So that's what this tells us. And the diagonals dissect each other. Okay, let's see. So there's the diagonals. And it's a little hard to tell, but that would be the midpoint. And so this has got to be equal to that. That is equal to that. So that tells us the diagonals bisect each other. And then the area is just the base times the height. Because really, if you think of it, you just take this area right here and put it over here, which they did here, it's just a rectangle. So that's the equation of a rectangle for the area. Now next, I'm going to look at the properties of this is not really a parallelogram because a parallelogram is a two-dimensional object. This is a three-dimensional object. It has depth. So this is actually a rectangular prism. But what I'm going to do is I'm going to turn this three-dimensional object into a two-dimensional object just by tracing the outline. And then we'll start looking at this outline and seeing what it tells us. So I'm turning this three-dimensional object into this two-dimensional object right here to validate these properties. Let me finish drawing the lines here. So we get a halfway decent representation of this thing. Okay, so there's our representation of a parallelogram. Now, what we want to do is opposite sides are equal in length. So let's just measure these opposite sides, the length of them. We use our millimeter. Everything's going to be in millimeters. So that we're going to call 100. 100 millimeters. This is approximately another 100. But units of millimeters. So this side right here looks to be about 45 millimeters. And this is not totally exact. This is something I made, and it's 45 to 46 millimeters. But basically, the opposite sides are equal in length. So this is equal to this approximately equal to this, within manufacturing tolerances and measuring tolerances. We're taking the ideal of a parallelogram, which is a mathematical construct, breaking it down into an actual physical object. So now let's measure the opposite sides. Opposite angles are equal. Okay, I've got a protractor here. First of all, let's measure this angle right here. Get that on there. And so this angle is going to be greater than 90 degrees. So I'm going to have to use this scale right here. It looks like about 119 degrees. So that's 119 degrees. Now I flip it over here. Put this protractor on this again. And now it looks like it's about 118 degrees. So this is 118 degrees. Now I'm going to measure this angle right here. I'll get it on there. Okay, so that looks like that's going to be an angle less than 90 degrees. So I'm going to use this scale right here. It looks like it's about 61 degrees. Now I want to measure this angle over here, the opposite angle. And I'm going to say it's also about 61 degrees, give or take a little bit. Okay, so what does this tell us? So opposite angles are equal. So these are within measurement tolerances, manufacturing tolerances are equal. This angle and this angle are equal. Okay, so far the first two criteria for this being a parallelogram have been met. So now let's look at the diagonals bisect each other. Okay, so let's draw these diagonals here. They go from corner to corner. And go to corner to corner. Okay, there's our diagonals. Now this third property tells us they bisect each other. So this distance has got to be equal to that distance is equal to that distance. Let's just measure this and see what they are approximately. So that is about 42 millimeters. This one looks to be about 43. Close enough. So this is about 64 millimeters. And this distance is going to be about 63 millimeters. Okay, so this distance is equal to this distance. That checks. This distance is equal to this distance, approximately, the measurement. That checks. So we've just determined that truly this is a parallelogram. Now, let's calculate the area, base times height. Now, we've not really measured the height, which is going to be this distance right here, so let's measure that now. That looks right at 40 millimeters. So this distance from here to here, h, is equal to 40 millimeters. And we already know the base is 100 millimeters, so the area is going to be the base times the height. The base is 100 millimeters times 40 millimeters. That's 4,000, and the units on that would be millimeter squared because it's millimeters times millimeters. So there we go. We showed that this effectively is an approximation to a parallelogram, at least this surface. We calculated the area just of this surface, not the sides or the back included, just this one surface. So that's what that tells us there. Hope you got something out of this video and learned a little bit about parallelograms, measuring area and taking measurements. Well, thank you for watching.